Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from November 2023. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 5 to 9, which account for 23 of these marks. Eduqas Component 1 papers are non-calculator papers, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 5a. Lucy writes down the first 5 square numbers. Lucy chooses 2 square numbers that have a difference of 12. Which square numbers did Lucy choose? Okay, so let's do what Lucy did to start off with. Let's write the first 5 square numbers. So remember, a square number is the product that you get when you multiply a number by itself. So for example, 1 squared is 1 times 1, which is 1. Okay, so 1 is a square number. 2 squared is 2 times 2, which is 4. So 4 is the square number. 3 squared is 3 times 3, which is 9. So 9 is a square number. 4 squared is 4 times 4, which is 16. So 16 is a square number. And 5 squared is 5 times 5, which is 25. So 25 is the square number. So that's the first 5 square numbers. 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So we're looking for 2 numbers that have a difference of 12. Okay? So 1 doesn't have a difference of 12 with anything, but I can spot that 4 and 16 have a difference of 12. So they're the 2 that I'm going to go with. We're going to go with 4 and 16. Part B. Mary adds 2 odd numbers together and gets an answer of 21. Could Mary's answer be correct? Yes, no, or we cannot tell, and you've got to give a reason for your answer. Okay, so I am going to say no, Mary's answer is not correct. Okay, and the reason why it's not correct is I know that an odd number plus an odd number always makes an even number. All right, but 21 is an odd number. So I've explained, I've given a reason, okay, but I'm just going to explain to you guys why. So if, for example, let's think of an odd number, 1. So if I was to go 21 take away 1, that leaves me with 20. 20 is an even number. If I was to pick the next odd number, so 3, 21 take away 3 is 18. So whenever you take an odd number from an odd number, you're going to get an even number. So an odd, add an odd is even, but 21 is odd. So that's why Mary is not correct. Part C. Write the following values in ascending order. So ascending order means going up. Okay, so we want them to go up. So we want them to go from smallest to greatest. So when we're ordering mixed numbers like this, so decimals and integers, we need to be really careful. So what I'm going to do is I'm going to write a column down here, and I'm going to match everything up to the appropriate decimal places. So 3 is 3 whole ones. 0.3 would be 0.3. I'm lining that decimal point up, guys. 0.302, 0.35, and 0.8. It's really important when we're comparing numbers that we have everything in the correct place value columns. Okay, so I'm going to look at this column first. Okay, everything in that ones or that units column is 0 apart from 3. So this is definitely going to be my greatest value. So I'm going to put 3 there as my greatest value and cross it off so I know that I've dealt with it. Now we're going to compare the numbers that are remaining. So in the ones, the units column, we've got 0. So everything matches. We can't do much there. In this column, we've got 3, 3, 3, 8. So this is all in the tenths column. So these 3 match in the tenths, but 8 is bigger. Okay, so 8 tenths is bigger. So 0.8 is going to go there. So let's get rid of that one. Now that we're comparing these, I'm going to make these numbers the same size with placeholder zeros because I need to be able to compare each column. So the tenths column matches, so we're going to move over to the hundredths column. So in the hundredths column, we've got a 0, and a 5. 5 is bigger than 0 and 0, so that would be the next biggest value. So that's 0.35. Now we're comparing the last two numbers. So they match in the units and the ones, they match in the tenths, they match in the hundreds, so we now need to compare the thousandths. So we've got 0 and 2. 2 is bigger than 0, so 0.302 will go there, and then 0.3 is the smallest value. Question 6a. 25 players in a rugby team voted for their player of the season. Part 1. The 3 nominations for player of the season were Ashton, Jamal and Oliver. So we've got Ashton, Jamal and Oliver. The frequency table shows the tally of the votes from 10 of the players. Okay, so 5, 4 and 1, 10 of the players so far. The remaining 15 votes are shown below. So these are the candidate that the other 15 people have voted for. Which player won the vote for player of the season? You must show all your working. So what we need to do here is put those 15 votes here into this tally chart. Okay, and then we can look at the frequency, and the person with the highest frequency has the most number of votes, so they will have won and they will be player of the season. So let's go through this systematically. So Ashton, so put a tally in Ashton, cross him off. Oliver, Jamal. So here, remember the tally, we go 4 and then we cross through, we make a gate for 5. Oliver again. Oliver, Jamal, Oliver, Oliver, Jamal, Oliver, Ashton, Jamal, Oliver, Jamal, Jamal. Okay, so we're going to total up the tallies now. So 5 plus 2 is a frequency of 7. 5 plus 5 is a frequency of 10. And 5 plus 3 is 8. So there's a frequency of 8 for Oliver. And I'm just going to double check that I've not missed anyone out. So we have 25 players in total. 7 plus 10 plus 8. So that's 17 plus 8 is 25. I just wanted to check that I'd included everybody, that I'd not missed somebody out and messed up when I was doing that. Okay, so remember, the person that won the vote for player of the season has the highest number of votes. So the highest frequency, 10 is higher than 7 and 8. So Jamal won the vote. So we're going to put the player of the season is Jamal. It says show your working. You've shown your working. You've tallied, you've totaled the frequencies. You've even done a check to make sure we've included everybody. Part 2. What percentage of the 25 students voted for Oliver? Okay, so 8 out of 25 voted for Oliver. So I'm going to default to a fraction to start off with. But remember, we want it as a percentage. A percentage is out of 100. So I'm going to scale up my fraction to an equivalent fraction that has a denominator of 100. There are 4 25s in 100, so I would have multiplied by 4 here. I need to do the same to the numerator. So 8 multiplied by 4 is 32. So 32 out of 100 votes for Oliver. Percentages are out of 100, so I can write that as 32%. Part B. Some of the players in Lindsay's team have missed games because of injury. She writes a question to find out how many games they have missed. Here's the question. So Lindsay's question is, how many games have you missed this season due to injury? 0 to 2, 2 to 4, or 5 or more. And then the question is asking us to state one criticism of her question. So my criticism is that there's an overlap in the response boxes. Because if somebody missed 2 games, do they put their tick here or here? Because both of them include 2. So we're going to write that down. There is an overlap in the response boxes for anyone who missed 2 games. Question 7a. Robin has a scale drawing of his local park. The scale on the drawing is 1 centimetre represents 250 centimetres in real life. So every 1 centimetre on the drawing is 250 centimetres in real life. On the drawing, a flower bed is 6 centimetres long. What is the actual length of the flower bed? Write your answer in metres. So the first thing to notice here is they say write your answer in metres. Everything's in centimetres. So at some point we're going to need to convert from centimetres to metres. But to start off with, let's deal with finding out the actual length of the flower bed. So I'm going to draw myself a proportion table. We know how I enjoy these. So we're going to do the drawing and we're going to do the actual length. So the length in real life. So on the drawing, 1 centimetre represents 250 centimetres, okay? On this particular drawing, the flower bed is 6 centimetres. I'm going to remind myself here as well that we're in centimetres. So what I would do to convert this is scale up. So I would multiply by 6 here to get from 1 to 6, but I have to do the same on the other side. So I'm doing 250 multiplied by 6. 6 multiplied by 0 is 0. 6 multiplied by 5 is 30. So we're going to write the 0, carry the 3. 6 multiplied by 2 is 12. Add the 3 is 15. So it's 1,500 centimetres in real life. But we want our answer in metres. Okay, so 1 metre is 100 centimetres. So 1,500 centimetres divided by 100 is 15 metres. So the actual flower bed is 15 metres. Part B. Robin has 240 daffodils and 60 tulips. What fraction of these flowers are daffodils? Give your answer in its simplest form. Okay, so when we're dealing with fractions, remember the denominator is the total number of what we have. So we need the total number of flowers because it's what fraction of the flowers. So we've got 240 plus 60, which is 300. So we'll have a denominator of 300. They want to know what fraction of these flowers are daffodils. Well, 240 of them are daffodils. We need to give our answer in its simplest form, guys. That's the important thing. So you've potentially only got 1 mark here. So I know I can divide the numerator and denominator by 10, which gives me 24 over 30. I also know that 24 and 30 can be divided by 2 because they're even numbers. So 24 divided by 2 is 12. 30 divided by 2 is 15. Now I know that 12 and 15 are both in the 3 times tables. I'm going to divide by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. So my final answer, nice and clearly, is 4/5 of those flowers are daffodils. Part C. Some rose bushes are divided equally between 2 gardeners. Write this division as a ratio. So they're divided equally between 2 people. So if it's between 2, they get half of them each. Okay? So for example, if we had 10 rose bushes, each gardener would get 5. If we had 4 rose bushes, each gardener would get 2. If we only had 2 rose bushes, each gardener would get 1. So I'm going to write that as a ratio of 1 to 1. Question 8. A shop sells the same brand of lemonade in 2 different size bottles. So we can get 1,000 millilitres for £2.50 or 300 millilitres for 81 pence. Which bottle is the better value for money? So we can select which bottle. You must show all your working out. So we're not going to select anything until we've done some working out. And we need to convert these to be equal amounts of lemonade so we can compare the cost. Okay. So I'm going to do a little table here for the big bottle. Okay. So that's millilitres and cost. And this is the bigger bottle. So 1,000 millilitres is £2.50. And then I'm going to do a little table for the smaller bottle. So millilitres cost 300 millilitres is 81 pence. So 0.81 in pounds, because I want to be able to compare. We work in pence or pounds, it's whatever you're comfortable with. So I need to scale these up to have the same amount. So I'm going to scale up to 3,000, because I can multiply this by 3 to make 3,000 millilitres, and I can multiply this by 10 to make 3,000 millilitres. Okay, when I multiply this side by 3, I need to multiply this side by 3, so that becomes £7.50. When I multiply this side by 10, I have to multiply this side by 10, which becomes £8.10. Okay, so we're going to look at these two value nows. We want the better value for money. So we've got them both here. For 3,000 millilitres, it costs £7.50 in the bigger bottle. But for 3,000 millilitres in the smaller bottle, it costs more. It costs £8.10. So the 1,000 millilitre bottle is the better value. (9a). Solve. 6x equals 42. So remember, 6x is the same as 6 multiplied by x. To solve an equation, we're isolating the variable, so we want to get x on its own, so we need to do inverse operations. The inverse of multiplying by 6 would be to divide by 6. So 6 multiplied by x divided by 6 gives us x. We have to do the same to both sides to balance the equation. 42 divided by 6 is 7. Part B, calculate the value of 4y when y equals -12. So this is a substitution question. We know what y is equal to. We need to substitute it into the expression 4y to find out the value of the expression in total. So 4y is 4 times y. We know that y is -12, so we're doing 4 times -12. A positive times a negative gives us a negative, and 4 times 12 is 48. Part C, simplify. 5w, add 3, and then in brackets 6w, subtract 2. So the first thing I need to do is expand that bracket. So 5w plus, so I'm expanding the bracket, 3 multiplied by 6w, subtract 2. So 3 multiplied by 6w is 18w. 3 multiplied by -2. A positive multiplied by a negative is negative. 3 multiplied by 2 is 6. So this bracket can be written as 18w subtract 6. Now we're going to collect like terms. And by collect like terms, I mean put together anything that has exactly the same letter and exactly the same power, or anything that are just numbers. So we have 5w plus 18w. That plus tells us that we're adding. So 5w plus 18w. Well, 5 plus 18 is 23. So we have 23w subtract 6 as our simplified expression. Got nothing else to combine that subtract 6 with, so it stays as it is. D. A shirt has T buttons. Write down in terms of T the number of buttons on 8 shirts. So if there are T buttons on one shirt, the number of buttons on 8 shirts would be 8 times T. However, we'll know from looking at the previous questions, we don't need to write the multiplication symbol here. We can just write 8T as an expression for the number of buttons on 8 shirts.